All right, so good morning. So today we're going to start by looking at the parallelogram. And this says that, and of course, we're doing area and perimeter. So we're looking at formulae for calculating the area of a parallelogram. So this says that a parallelogram is a quadrilateral in which opposite sides are equal and parallel. A parallelogram is a quadrilateral in which opposite sides are equal and parallel. All right, so for example, if this side here to the left is A, it means that this side here to the right is also A. If the side at the bottom is B, it means that the side of the top is also B. A parallelogram is a quadrilateral in which opposite sides are equal and parallel. What else? Opposite angles are equal. So the angle here and the angle here, those are called opposite angles. Opposite angles of a parallelogram are equal, and adjacent angles are equal. Sorry, adjacent angles are supplementary, meaning that they add up to 180 degrees. All right, so it's important sometimes to understand the properties of these shapes. So adjacent angles would be like the one here on the left and the one here on the right. Those two angles, alpha and theta, add up to 180 degrees. And opposite angles are equal and adjacent angles are supplementary. Guys, the formula for calculating the area of a parallelogram is 1. The first formula is the area is equal to B times H. So let us say that B is sort of like the length of the base and H is the height. Please notice again that height is associated with the right angle. And if there's no right angle, there is no height. Another way you could calculate the area, it would be AB sine alpha or AB sine theta, where A and B are the lengths of the sides. So this is the side A, this is the side B. The angle between them is alpha. So the area is AB sine alpha. This is B and this is A. The angle between them is theta. So the area is AB sine theta. Now, either AB sine theta or AB sine alpha, both of them will give you the same answer. So the area in this case is the product of any two adjacent sides and the sine of the angle between them. The area would be the product of any two adjacent sides and the sine of the angle between the two sides. Guys, the area of a parallelogram is B times H, or the area of the parallelogram is AB sine alpha or AB sine theta. All right, let's talk about the rhombus. Now, the rhombus is a special type of parallelogram in which all four sides are equal and the two unequal diagonals bisect each other at right angles. The two unequal diagonals bisect each other at right angles. Therefore, the rhombus is a special type of kite. Can everybody look at the rhombus and see that it sort of looks like a kite? Can everybody see that?
Yes, sir.
Good. So the rhombus is also a special type of kite. So there are three quadrilaterals that you could use the formula for calculating the area of a kite to calculate. The square is a special type of kite. The rhombus is a special type of kite. And of course, the kite is a kite. So the square, the rhombus, and the and the kite, the formula for the area of a kite can be used to calculate the area of the square and of the rhombus and of the kite. All right, and that area is the area is equal to d1 times d2 divided by 2. That is the formula for the area of a kite. And of course, the square and the rhombus, they're both a special type of kite. Guys, can anybody tell me maybe what is the difference between a square and a rhombus? Who can maybe just point out just one difference or one or two difference between the square and the rhombus? Anybody? All right, you don't have to point it out. I can point it out. Here's the thing that is the same about them. Both the rhombus and the square have all four sides are equal in length. Now, the thing about the square is that all four interior angles measures 90 degrees. That is not the case about the rhombus. Another difference between the square and the rhombus is that the square, the two diagonals are equal in length. With the rhombus, the two diagonals are not equal. But in both the square and the rhombus, the diagonals bisect each other at right angle. And this bisecting each other at right angle makes both the square and the rhombus a special type of kite. Ladies, gentlemen, the area of the rhombus is B times H. The area of the rhombus is B square sine theta, where B and B times B gives you B square, are the lengths of the two sides, and theta is the angle between them. The area of the rhombus is D1 multiplied by D2 divided by 2, because the rhombus is a special type of kite. Guys, example 7. Example 7 says example 7a says calculate the area of, let's turn the page. All right, so we have two parallelograms, well, it looks like, yeah, two parallelograms. We need to, well, the top one is a parallelogram, the bottom one is a rhombus. Can anybody tell me how we know that the bottom one is a rhombus? Anybody? This is a parallelogram.
Side have 4 equal sides.
Basically,
4 sides are equal.
The strokes here are telling me that all of these sides are equal. The strokes there are telling me that all four sides are equal. So whereas the top now, up here, the double stroke here and the double stroke over here, it should be a double stroke over here, are telling me that these two sides are equal. And the single stroke and the single stroke here is telling me that those two sides are equal. So the top shape is a parallelogram, whereas the bottom shape is a rhombus. Guys, I'm going to calculate the area of the bottom one, and I want you to calculate the area of the top one. Now, guys, the area of this rhombus, the area of the rhombus is equal to this one. I know the base and I know the height, so it's equal to BH. This is equal to 6 times 5.2. The answer is, what is this? 31.2? 31.2, and the unit is centimeter square. Just a reminder, remember that area is a measure of surface. So when you calculate the area, what you're calculating is the amount of that shaded space. You're calculating a value for the amount of that shaded space. Area is measuring what? Surface. So the 31.2 centimeter square is that shaded area. Very quickly, guys, for I, calculate the area of the rhombus, sorry, of the parallelogram at I and type your answer in the chat. All right. So for I, the area of the parallelogram all right, based on the information I have, the formula I'm going to use is AB sine theta. All right, so I'm using the fact that if this side is 9, it means that this side is also 9. So this is 9 meters. So the two sides are 9 and 6, and the angle between them is 68 degrees. So from my formula, A could be 6 times B, which is 9, times the sine of the angle between them, which is 68 degrees. This is 54 sine 68. You would just put this in a calculator and press equal. And I believe when I did, I got my answer to be 50.1 meters square. And this is to 3 significant figure. So the area of the parallelogram would be 50.1 meters square. Please remember that your syllabus says, if unless otherwise stated, you must write your answer to 3 significant figure. Let's have a go at B. Let's see what B is saying. All right, so B says PQRS is a rhombus. So this is a rhombus. So all 4 sides are equal. Opposite sides are parallel. All 4 sides are equal. Opposite sides are parallel. The shape is a rhombus. We're told that PO is 3.6 centimeters. We are told that OQ is 2.7 centimeters. And we're asked to calculate the length of PQ. We're asked to calculate the size of angle QPS to the nearest meter, to the nearest degree. And I think then we're asked to calculate the area of the entire rhombus. We're asked to calculate the area of the rhombus. Guys, let me give you 6 minutes to see what you can come up with where this is concerned. What I did already is I placed in the figures as is stated in the question. I placed in the length of PO, the length of OQ. We're asked to calculate the length of PQ. So we're asked to find this length here. Let's call it X. And then we're asked to find angle QPS. You must identify that angle and calculate it. And we're also asked to calculate the area of the entire rhombus. All right, guys, let's see what you can come up with in 6 minutes. So again, let's just read over B. B says PQRS is a rhombus. And so because it's a rhombus, we're able to put in all those fancy things. Opposite sides are parallel and all 4 sides are equal in length. Here's the next thing about a rhombus. The diagonals meet each other at right angles. So therefore, the diagonals bisect each other. So this one and the side here, they're equal. This side and this side are equal. So in other words, the diagonals of a rhombus divides the rhombus into 4 identical right angle triangles. The diagonals of the rhombus divides the rhombus into 4 identical right angle triangles. So let's have a look at this right angle triangle. Let's have a look at this blue right angle triangle. We're asked to calculate PQ. If I know two sides of a right angle triangle and I wish to find the length of the third side, I must apply Pythagoras theorem. So the Pythagoras theorem formula is c squared is equal to a squared plus b squared. And in this formula, c is the hypotenuse and a and b are the other two sides. So for this triangle, the hypotenuse is the side in front of the right angle. So the hypotenuse is x. So x squared is equal to 2.7 squared plus 3.6 squared. So let's work this out. So 2.7 times 2.7 is equal to 7.29. So this is 7.29 plus 3.6 times 3.6 is equal to 12.96. And when you add these, you're going to get 20.25. The opposite of square is square root. And so x, which is PQ, is equal to the square root of 20.25. So PQ, which we're asked to find, is equal to, so we need the square root of 20.25. The square root is 4.5 centimeters. PQ is 4.5 centimeters. Next, we're asked to calculate the size of angle. We're asked to calculate the size of angle angle PQS. So let's change to green for that one. Angle PQS. So angle PQS is this entire angle. Angle PQS, PQS, that's that entire angle there we need. Now, the best way to find this is to find it in pieces, using the fact that these two angles are equal. So what I'm going to do is I'm going to find one and multiply it by 2. So let us take out the triangle PQR. Let's take out the triangle PQR. Sorry, PQO. This is triangle PQO. I just took out the triangle PQO. This is triangle PQ. Sorry. PQO. This is the right angle here. This is 3.6. This is 2.7. It's a right angle triangle. I want to find this one. Now, I know that those two angles there are equal because remember I told you that the diagonals of the rhombus divides the rhombus into 4 identical right angle triangles. The diagonals of the rhombus divides the rhombus into 4 identical right angle triangles. Kezia, I'll come back to your question. Can it wait until the end?
So I was asking if it's the triangle PQ or QPS.
We're asked to find PQS. But to find PQS, I'm going to find PQO first. I'm going to find this angle here. Sorry, QPO. And then I'm going to multiply it by 2 to get the entire angle PQS. Guys, tell me, what is this side to the angle? Anybody? Talk to me, people. Opposite. What is 3.6 to the angle?
They're adjacent.
Adjacent. Which angle, which trig ratio includes opposite and adjacent?
Sir, tan.
So I'm going to say tan is equal to opposite over adjacent. Then I'm going to say the tangent of the angle theta is equal to opposite 2.7 over adjacent 3.6. So theta is equal to tan inverse 2.7 over 3.6. So theta is equal to let's find this. So it's second function. So I go shift, then sine, open bracket, 2.7 divide by 3. So it's not sine, it's tan. So it's shift, then tan, open bracket, 2.7 divide by 3.6, close bracket, press equal. The answer here is, call it 36.9. But since they're set to the nearest degree, it is 37 degrees. It means, therefore, that angle QPS would be equal to 37 plus 27, 37 plus 37. So this would be 72 degrees. The angle is 72 degrees. All right, so this entire angle here is 72 degrees. Now, the last thing we're asked to do is to calculate the area of the entire, of the entire rhombus. Go ahead, Ranique.
74, not 72.
Say that again.
74 and not 72.
74. Thank you, Ranique. All right, so this is 74 and not 72. (74 degrees). All right, let's go for the area of the entire rhombus. So I'm just going to try and do a quick sketch of it. This angle is, this is QPS, and it is 74 degrees. This side here is 4.5. This side is 4.5. The area is equal to b square sine theta. So this is 4.5 square, the sine of the angle between them, which is 74 degrees. The area is, so let's find this out. So the area is 4.5 times 4.5, the sine of 72 degrees, 74 degrees, close bracket, and this is saying that the answer is 19.5 meters squared. So the answer here is 19.5 meters square. I think it's meter. They want the length, the angle to the nearest degree, and then the area is 19.5.
So it's centimeter.
All right, just jumping back quickly to check. It's 19.5 centimeters square.